Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kairuna bin Hasni. My medical number 09DE23F1018.
Assalamualaikum warahmatullahi wabarakatuh and hi everyone. My name is Azim Karadi bin Azrin. My matrix numbers is 09DEE23F1041.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firizam Zain Abidin. My matrix number is 09DE23F1028. Okay, apa itu soldering iron? Soldering involves using a heat tool, make solder and join metal parts, often in electronic or plumbing. Because it involves high temperature, molten metal and potential hazardous fume, it's important to follow safety guidelines. Here are key soldering safety guidelines to ensure a safety work environment. 5 basic safety guidelines while handling a soldering iron. First, work in a well-ventilated area. Reason is solder can release fumes, especially if you are using solder that constantly leaks or flood with chemicals. Inhaling this fume can be harmful. So, the solution, use a fume extractor or work near a fan. Consider wearing a mask if ventilation is insufficient. Second, wear protective gear. First, we have gloves. Protect your hands from hot solder splashes and burns. Second, safety glasses or goggles. Protect your eyes from splashes of molten solder or flux. Third, clothing. Wear long sleeve to prevent burn from accident contact with the soldering iron. Third is handling the soldering iron with care. Keep the hot tip pointed away. Never touch the tip of the iron if can reach temperature of 300 Celsius equal 517 Fahrenheit or more. Always place the iron in a stand. Use a soldering iron stand when not active, using the iron to avoid burn or fire hazard. 4 is avoid the direct skin contact with soldering or flux. Solder and flux can irritate the skin and some may be toxic. Wash hands thoroughly after handling solder or flux. Lastly, avoid ingesting hazardous materials. Do not eat or drink in the soldering area. Lead and chemical from flux can easily contaminate your food or beverages.
Today, I wanted to talk about a soldering technique, which is a good soldering. First, the solder needs a clean surface on which to adhere. Buff the copper foil of a PC board with steel wool before soldering. Remove any oil, paint, wax with a solvent, steel wool or fine sandpaper. Next, to solder, heat the connection with the tip of the soldering iron for a few seconds, then apply the solder. So, the step is heat the connection, not the solder. Hold the soldering iron like a pen near the base of the handle. Both parts that are being soldered have to be hot to form a good connection. Number 3 is keep the soldering tip on the connection as the solder is applied. Solder will flow into and around well heated connection. Use just enough solder to form a strong connection. After that, remove the tip from the connection as soon as the solder has flowed where you want it to be. Remove the solder, then the iron. Caution: don't move the connection while the solder is cooling. Number 6. Don't overheat the connection, as this might damage the electrical component you are soldering. Transistor and some other components can be damaged by heat when soldering. A crocodile clip can be used as a heat sink to protect these components. Number 7. Inspect the joint closely. It should look shiny. If you are soldering a wire onto a PC board, it should have a volcano shape. If the connection looks bad, reheat it and try again. Number 8. Wipe the tip of the iron on a damp sponge to clean it. The tip should now be shiny. And the last one is unplug the soldering iron when it is not in use. That's all from me. Let's go to the next part.
Today, I want to talk about soldering technique in bad soldering. Bad soldering, unfortunately, there are many ways for soldering joint to go wrong, as solder always seem to go where it's supposed to, like this picture. First, soldering bridging. Soldering bridging of the many problems caused by smaller and smaller components. Solder bridging take the top of the list. A solder bridge is formed when 2 points on the circuit board that should not be electrically connected are inadvertently connected by solder during PCB soldering. This will form an electrical short circuit, which may cause various damage depending on the circuit structure. It usually due to excessive application of solder between joint or soldering tip that are too big or too wide, or the angle when the soldering iron is withdrawn is unfortunate. Identify a soldering bridge can sometimes be challenging, as solder bridge can be microscopic in size. If left detected, it can lead to a short circuit and cause a component to burn up. Second, excessive solder. Is you can get associated and apply too much solder on a pin. Excess boiling up is a wet you get characterized by its rounded and rice shape. That's the reason is that the solder withdrawal is too late. A common beginning assumption is the more solder the better, but while more solder should increase the amount of material forming the joint, it is difficult to know what actually happened beneath that mass of solder. There still lies a possibility neither the pin nor the pad is properly wet. On the one hand, this wastes solder. On the other hand, it increases the risk of solder bridge formation and may contain other defects, so it's better to be safe than sorry. Enough solder to adequately wet the pin and the pad thoroughly is usually sufficient, and the concave surface remains the best shape to have, as it allows us to better assess the wetting of the joint. Third, soldering balding. Soldering balls are also one of the most common soldering defects that occur typically with the wave or reflow soldering. It appears as a small spear of solder that at rest adheres itself to laminate, resist, and conductor surface. Solder balls may be caused by many factors, mainly due to the following two reasons. First, when soldering printed board, the moisture near the throat holes on the printed board will become steam due to the heat. Second, the solder ball produced on the reverse side of the printed board is caused by improper setting of some process parameters in wave soldering. Is the amount of flux coating increased or the preheating temperature is set to low. Fourth, coil joint. The surface of the coil joint appears dull, lumpy, and pock-marked. This is typically caused by insufficient heat being transferred to the joint to completely melt in the, which may be a result of a number of different things. The soldering iron of the joint itself may not have been given enough time to heat up successfully. The iron temperature may not be set high enough to melt the particular solder type being used, such as lead-free solder has a higher melting temperature, or is made a result of the design of the pad and trace themselves. For example, a pad connected directly to the ground planes without thermal relief consideration will cause the heat of the solder iron to be lost to the ground plane. If you feel a stubborn solder joint, that refuse to liquefy, then the design may be a fault. Cold joint is the same as vertical welding. It is difficult to fully expose during the production process. It often requires use it for a period of time, which may be days, months, or even years. This will not only have extremely bad effect but cause extremely serious consequence because the strength of the cold welding is low, then conductivity is not good. Fifth, overheat joint. Just as too little heat will cause wonky joints, too much heat will also give you a splitting headache. Overheated solder joints have white solder joint, no metallic luster, and rough surface. Overheated solder joint can result from the solder iron temperature being set too high, or result from solder foil failing to flow, possibility due to the surface of the pad or lid already having a layer of oxide, preventing surface heat transfer and therefore leaving your heating the joint for too long. Hopefully the damage caused will be served, but it's made bad to leave entirely, killing the board or requiring costly repair. Insufficient wetting, throw hole. Joints that are not fully wetted or weak and do not form a strong connection with the board. Ideally, the solder should achieve 100% wetting with the pad and pin, leaving no gaps or space exposed. Insufficient wetting of the pins and the pad result from failure to apply heat to both the pin and pad, and not giving the solder enough time to flow. Most of the reasons are that the surface of the welding area is contaminated or is stained with solder resist, or a metal oxide layer is formed on the surface of the bonded object. 7. Insufficient wetting, surface mount. Similarly, SMD component can also suffer from insufficient wetting. In the image above, 3 pins of an SMD components do not have good wetting with their respective pad. The solder on the pins had failed to flow onto the pads as the pin was heated instead of the pad. This will cause mis-soldering or less soldering failure, which may cause component to fall off. Solder starved. As its name suggests, a solder starved joint doesn't not have enough solder to form a solid electrical connection. The solder does not form a smooth transition surface. Here is a likely the insufficient heat was applied to the lid, resulting in a poor connection. There are many reasons for solder starved, including: first, poor solder fluidity or premature solder withdrawal. Second, infusion flux. Third, the welding time is too short. It's possible that this joint will work as there is still electric contact made, but the mechanical strength is not high. Nevertheless, a solder starved joint is likely to fail eventually as crack develop over time and weaken the joint. Let's go to the next part. Okay guys, ini cara-cara nak solder guys. First, korang ambil barang macam ni. Lepas tu, standby. Ni adalah pan minyak. Lepas tu, kena setting dia punya temperature. Sebab nak bagi solder tu function dengan baik tak terlalu panas, tak terlalu sejuk. Lepas tu, kita boleh bersihkan PCB menggunakan alkohol untuk lebih safety. Lepas tu masukkan komponen. Lepas dah masukkan komponen dengan baik, kita apply flux. untuk soldering. Seterusnya time to solder lah. Time to solder, kita testing solder dengan timah. Make sure tak terlalu cair dan tak terlalu sejuk untuk mendapatkan connection yang perfect. Ini adalah perfect joint, okey. Lepas tu kita boleh trim kaki lebih. Okay, that's it. Okay.
Guys, untuk korang lebih faham, saya akan tunjukkan korang video good soldering and bad soldering. Okay, untuk yang pertama, yang kedua ni. Yang pertama adalah kurang timahnya. Yang kedua, timahnya tidak bersentuhan dengan PCB. Dan yang ketiga, dia bersentuhan dengan yang sebelah. Yang keempat, menunjukkan soldering yang bagus atau good soldering. Sama juga dengan nombor 5. Dan yang terakhir itu adalah soldering yang salah, di mana timahnya terlalu banyak. Okay guys, ini pula merupakan video cara untuk desoldering. First, korang perlu ada solder sucker. Second, korang panaskan timah dan korang ambil solder sucker dan sedut menggunakan solder sucker tersebut. Kemudian selepas korang buat macam tu, korang dah boleh cabut komponen yang korang nak cabut. Okay, itu saja.